It was already late in the afternoon. I could see out the window it was raining. In 2 hours, it's going to get dark. That's London in December. I needed to quickly test the customer's application on Linux before the 3 p.m. meeting. I opened Docker Desktop, wait for it to start up, configure a container, deal with the volume mount, then the permissions, which, while rushing, I got both wrong. Then, finally, I got my environment running. The MacBook's fan kicks in as Docker swallows the CPU like a cookie monster. As I work, the shared file system lags just enough to be annoying, and I notice the battery draining faster than expected. There has to be a simpler way to run Linux environments on macOS without all this overhead. Everyone needs VMs for building, testing, and running software. We use them daily even without noticing. We find paths around them when we need to build code for different operating systems. Some of us use costly machines running on AWS or similar platforms. Others try to do the same with Docker containers, running locally, which in some cases is just abusive to the computer's resources. But what if I told you there's a better way? A solution that isn't only faster, it's lighter to run, maps your ports with the virtual machine, automatically mounts your local workspace, and is also fully compatible with all types of containers should you choose to run them. LimaVM started as a project aimed at promoting Containerd, the famous container runtime used by Kubernetes and other platforms. Containerd comes with its CLI, nerdctl. This was mostly addressing non-Linux users trying to run native virtualization without the overhead of Docker and the likes. But Lima grew way beyond that. It now supports all operating systems, allowing you to spin Linux VMs with minimal fuss. It automatically handling annoying parts like networking, file sharing, and port mapping. Lima has a developer-first mindset. It doesn't force you into GUIs or complex configs. There's a simple CLI that gets out of your way when all you need is work. Let me show you how it works. Before we can play with Lima, you'd want to install it. Mac users can install Lima and Qemu, the open source quick emulator for virtualization. Nix fans can get Lima directly with NixEnv. Once you've picked your poison, Lima Start sets you off with your first machine. There's always the option to tweak the config on the fly or choose an official preset, and we'll get to these later. Skipping configuration sets you up with the name default and an Ubuntu geared for Docker template for the new virtual host. If you pay attention, the VM isn't just starting itself. It also sets up a TCP port mapping for SSH, DNS queries, and a dynamic port for quick access. It also suggests we run Lima to open the shell. Lima is a shorthand for LimaCtl with the default machine as a target. For example, running Lima and then a command to install neofetch will automatically run it on the default machine we've just set up. Lima neofetch will now run it on our default machine and print the result, a beautiful Ubuntu running on top of an Apple Silicon. Yes, this felt weird saying as much as it is hearing, and it got allocated 4 CPU shares and 4 GB memory by default. Everything following Lima will keep going to the Lima machine, although ran from my local host. LimaCtl is our gateway for all things Lima machines. ls pops the running machines, allocated resources, and means of access. The docs at limavm.io list all the options and permutations to help you out. Remember the optional presets? Lima calls them templates. The ones with the golden star are called Tier 1 templates, which are officially tested by the team. You can find many Linux flavors, but also different container engines such as Docker and Podman, and yes, if you're on your way to orchestration, you've got Kubernetes and K3s, which is a lighter Kubernetes built for the edge, and others. Before we dive in further, let me tell you about today's sponsor, Twingate, the smart way to secure your remote access. You know how traditional VPNs are like having a single fortress gate? Once someone's in, they can wander anywhere. Well, Twingate flips this model on its head with zero trust security. Think of it as a modern city where every street requires its own access path, and a guard asks for your ID before you move on. Much safer, right? But here's what's really cool, especially for you developers out there, Twingate now seamlessly integrates with Kubernetes, so instead of bouncing between engineering and IT teams, you can configure secure access right in your YAML files, and it's all part of the regular engineering flow. No context switching needed, setup takes minutes, not days, and work across all of your devices. Plus, you get enterprise-grade security without the enterprise-grade headache. Whether you're managing a remote team or running a complex swarm deployment, Twingate handles the security heavy lifting, and you can focus on what really matters, building great software. Ready to level up your remote access security? Head over to twingate.com for a free trial and see why thousands of teams trust Twingate with their secure access needs. To use one of these templates, run a LimaCtl start template, : and the template's name. Here's the official Fedora template that comes with Lima. Now, we've got two running VMs. To access either, we run limactl shell and the VM's name. You might notice that the path in blue is familiar. That's because Lima mounted my local current path as well as my home directory, which in this case are the same. It's mounted directly to the VM and sets my path already with the open shell session. So my working directory is users/omerxx, just like I had on my local host, and my local files are here with me. I had to run uname just to make sure this is in fact an Ubuntu I'm using. I can access my Fedora instance with the same ease, mounting the path and attaching a shell where I can yum install libraries and play around. I mentioned in the intro how Lima was built to help introduce nerdctl and containerd. Well, running containers on LimaVM using nerdctl is incredibly simple. This line would send an Nginx Alpine container mapped to 8080 on the host to the VM. Note how this command, like others, is run on the host rather than inside a VM and addresses nerdctl with the .lima notation. Let's take a look inside the VM and see what's up when we run a containerd command. nerdctl ps doesn't show anything yet. On a split on my local machine, which is also the host under LimaVM's, nerdctl pulls nginx and ends up with a container hash as a response. Now we see the container within the VM running with a port mapping of host 8080 and the container's HTTP. Back to my Mac, localhost at 8080 reveals nginx, running a container inside a VM on my machine mapped all the way through in an almost transparent way. Remember, all of these came to life by running a simple VM from my local machine, then running the container from the same place and accessing the result from my browser. It really doesn't get any simpler than this. Not with Docker or Podman, surely not with Minikube and Kubernetes. All these have my utmost respect, but for local use, I think this is the peak if you value simplicity and things that just work. Let's shift gears, shall we? If you're after a Docker container for whatever reason, resetting the Docker host to the Lima Docker socket is all you need to enjoy the same process. Another option is to use the Docker context, which is very similar to Kubernetes context if you're familiar with these. We can create a new Lima Docker context and map it with the Docker socket under .lima. Check this out. I'll run exactly that, then Docker context use lima-docker. Now the same nginx from earlier run as Docker command as if I'm running any container on my Mac, but it's now pointing at my Ubuntu LimaVM. And there you have it, running inside the container, available under Docker PS and of course through my local browser. To remove a VM, we first must stop it, having Lima cut the socket and the network and everything else mapped. Then we can delete it altogether. But you didn't come here just for containers, right? Well, as a longtime happy Minikube user, I was very happy to see a Kubernetes template here. As Lima is a lightweight option, uses containerd, which is the Kubernetes modern container runtime, and can mimic a real from-scratch VM environment without any special presets. Minikube is incredible, but Lima gives it a fair fight, especially when resources are scarce. While I have my kubeconfig tooling, let's follow the Lima way and set the envar kubeconfig with the output of the command in the docs extracting kubeconfig.yaml. With the assistance of Claude, here's the simplest pod I could think of, using my own container I built and pushed to Docker Hub probably 10 years ago. Me and others have been using ever since as a lightweight placeholder that even responds to health checks. Only 5 megabytes inside. So, with kubeconfig set in my new shell, it's time to build the pod's YAML and apply it into my newly created cluster with Lima. Honestly, compared to Minikube, effort-wise, setting this up was just as easy, maybe even quicker. Food for thought. With the pod running, I think we can call this a success. It's important to stress that resources allocated by default to LimaVM can be easily tweaked through the YAML or by the command they start with, setting CPU, memory, even the volume type, which, by the way, Lima choose to run VirtuoFS. I hope I'm saying this right. It's a shared file system purposefully built at Red Hat for a local file system mounted to VMs with performance in mind. Okay, what if our precious VM is now a critical component that cannot get deleted? Lima comes with a protect command to make sure this doesn't happen. Try to delete a protected machine and it'll scare you away until the machine is unprotected back again. Longtime Docker users know the prune command that acts as a garbage collector and works the same with limactl. If you want to tunnel your way to Lima, making your localhost join as a guest to the network, that's also available, although still experimental. Lastly, Lastly, should you wish to create your own Lima template, that's easy. Head over to the Lima templates path. Homebrew has them under OPT Homebrew Share Lima templates, and add another YAML. The reference is available in the documentation. LimaCTL Validates helps with making sure the template is built correctly before it's run to assist as well. If you're interested, there's a very interesting KubeCon talk from 3 years ago talking about the effort of running a fully open source Kubernetes solution on Macs that featured localhost port propagation. They presented running K3s, Kubernetes' little lighter sibling, and other tools around it. Okay, with Lima, you're a VM monster. Now it's time to take this knowledge and leverage it with Podman. Check this video next to learn about the fastest, leanest, and best container setup, in my opinion, for those who work with Kubernetes, but also for any user who wants light and secure container setup that comes with an open source GUI that does a ton of work. It's also fully compatible with Lima, should you choose to run your pods on Lima VMs. Thank you for watching, and I'll see you on the next one.